Dah recording eh?
Okay.
Okay. Satu, dua, tiga. Assalamualaikum and a very good evening to Miss Alani Fatini. So my name is Nur Iman Batrisyia and I'm from the Department of Biomedical Engineering. So may I ask you to introduce a little bit about yourself first?
Waalaikumsalam. My name is Nur Iman Fatini. I'm from UiTM Arau, Diploma in Sport Management.
Okay, so for now, I am assigned to introduce to you regarding the 3D bioprinting, which specifically in the topic of tissue engineering. So actually, what is 3D bioprinting? So 3D bioprinting is a technique of printing complex biological human structures such as, for example, skin by using three things, which is viable cells, biomaterials, and also biological molecules. So the aims for this is to create scaffold with specific microarchitecture in order to provide mechanical stability and also to promote cell ingrowth. So this 3D bioprinting, it requires a very careful monitoring of in manufacturing the cells, in manufacturing the tissue, for example. This is to ensure that the cell viability is maintained throughout the process. So as you can see, this is a general step of 3D bioprinting. So there are three steps, which are pre-processing, processing, and also post-bioprinting. And for pre-processing or pre-bioprinting, this is where we select cells and also bioink preparation. And this requires 3D model creation from two methods, which is either CT or MRI scans. And also, after we made those scans, we need to convert all those 3D models into a printable format. And then we move on through the process of bioprinting. So during bioprinting, the bioink, which consists of three things: cells, nutrients, and also matrix, they are deposited layer by layer based on the digital model. So this process, they will construct printed according to the tissue type that we have already made during the CT and MRI scan. So the last step in bioprinting is post bioprinting. So the printed construct structure is, now we need to stabilize it through stimulation to support the tissue growth and also function. So this is to ensure that the tissue is properly growing and organized, and also its mechanical integrity. So next we move on to techniques in 3D bioprinting. So actually there are a lot of techniques of 3D bioprinting, but now I'm focusing to inkjet based bioprinting. So inkjet-based bioprinting is a technique that uses thermal or piezoelectric mechanisms. So this technique is, they will eject droplets of bioink, allowing for high resolution cell placement. So this technique, they can prevent cell death from drying out during printing, because the technique of 3D bioprinting is very, very, very what we call difficult. So the cells are encapsulated in hydrated hydrogels, so this will maintain the cell viability and also function. Next, we move on to what can we use for 3D bioprinting. So as I said just now, for my topic, I'm focusing more into the tissue engineering. So the application of 3D bioprinting in tissue engineering is actually to build realistic tissue in order to mimic cells and also biomaterials. So this in tissue engineering, 3D bioprinting can create specialized tissue models in order for like research and therapy, and maybe it can also be used for drug testing. So we doesn't need to use a real human model. And then it also can help engineer to have functional tissues and organs. And we can, by using 3D bioprinting in tissue engineering, we can also support tissue repair and regeneration in medicine. So there are challenges in 3D bioprinting. So there are three I stated here, but I'm going to focus more on the stimulating natural tissue complexity. as these challenges is very crucial because actually right now there are no bioprinted specimen that can be used, as the very difficult thing to in this process of 3D bioprinting is tissue vascularization. As we know, human tissue includes many blood vessels, so this is a very difficult thing in 3D bioprinting. So next is the future outlook in 3D bioprinting. uh, there are three I place here, which is enhance complexity and functionality of bioprinted tissues, AI and automation, which by using AI and automation, we can boost the precision, speed, and also cell viability in bioprinting process. And like I said just now, by having 3D bioprinting in future, maybe we can use the bioprinted tissue to offer realistic models for accurate drug screening and also personalized therapies. So that is all my explanation regarding the 3D bioprinting in tissue engineering. So Miss Alani, may I ask you two type of questions?
Yes, sure. What type of question you want to
So
ask?
uh, you haven't you haven't heard, have you heard regarding 3D bioprinting before?
No.
So, from your perspective, how do you think 3D bioprinting can impact uh, injury recovery in athletes? As you said, you are from the sports management department.
I think 3D bioprinting is a technology that creates structure layer by layer using living cells and spatial materials. For athlete, it could help by creating artificial tissue like
Mm-hmm.
cartilage or tendons to replace damaged ones. So this technology could help repair injuries more effectively by printing out structure that mimic the natural tissue, supporting better healing and reducing recovery time. And it might even help prevent re-injury by creating stronger, more natural tissue replacement.
Oh yes, I think so. I agree with you, as there are many issues regarding athletes, like the tangent injury. That injury is the one that I used to heal. So
Yeah.
the last question is, from your
Okay.
opinion, how do you think that 3D bioprinting can contribute to the development of customized prosthetics or rehabilitation devices for athletes?
Mm, I, in my opinion, 3D bioprinting could allow for the creation for prosthetic or rehabilitation device that are specifically designed to fit each athlete perfectly. Instead of using one size fit all solution, 3D printing will enable the production of device that match the unique of an athlete body or the specific needs of the injury. So this could improve comfort and make device more effective and help the athlete recover faster and more safely. I think so.
It's a very great answer from you. And thank you so much for your time. So have a great day. Thank you, Miss Alani Fatini.
You're most welcome.